seconds. Hey, $10. Okay, I think we're all good. I actually remembered to hit start streaming on YouTube. I should remember to put. It's fine. I think we can just get right into it. This is the second meeting on Chapter 6, and then we'll move on to Chapter 7. Well, we probably haven't decided that yet, I guess, but... Yeah, let's just hop into Discord. I'm in, and let me figure out what my questions are. Okay, I'm gonna bring in the next, or the... Last time we only did the first two questions I picked out, so this is the third one. Hey, $10.
Hello.
Hey.
Am I muted? I'm not muted, right?
I can hear you.
Nice.
Just turning you up a little bit. Okay. How's Saturday going?
Going well. Kind of cold here again.
Oh, it's hot here. It's like 90 something.
Oh my God, it's 51 here.
Oh my god. I wish we could take the average of the two temperatures. That sounds nice.
Yeah, wouldn't it be nice?
Oh yeah, Zach. I only just recently found out it existed. It's called Discord Stream Kit. It's made by Discord. It's super easy. Like, let me just give you that. It says install, but you don't actually install anything. It's just a browser source. Slim, thank you so much for the raid. Welcome in, everyone. I saw you doing some Fibonacci stuff. I hope it went well. Hey, Peach for who's here on my end, check out Kennedy's ideas. He's awesome. And for anyone who's new coming with the raid, this is the reading group on general relativity that we do on Saturdays. I'm in Discord with Fenbox Fan, who's been learning along with me. And we're talking about chapter 6 of this book, which will load in a second, Gravity by James Hartle. And we just got into the chapter Gravity as Geometry, which is getting into, it's getting closer to actual general relativity. Oh, nice, Slim. But yeah. So I pulled in number 4 from this chapter. So starting from the equivalence principle, the form stated on page 119, which I brought in a copy of below, using only freely falling frames and inertial frames, argue that light must fall in the gravitational field of the Earth. That is Dawn exclamation point? Yeah. What is the value of Dawn factorial? I don't know. I'm going to have to write a paper on that. Infinite? I don't know all that. So how can we use the equivalence principle to say this? If the frame is inertial, it can't be accelerating, I think.
Right.
Hey, Storm. But yeah, that's kind of what the question is asking. That's what we're trying to figure out. Like, why?
Whereas if it's freely falling, does that mean it's constant acceleration?
I think so, yeah. Is that equivalence principle though, Storm? Or
What's
I
your
don't
P
know.
stand for, Storm?
Yeah.
Is that just like the weight force? The weight force? Or maybe like a potential?
Potentially like an H in there. P is the weight.
P is the
Okay.
weight. Well, it feels like we need to draw
So
two different pictures, right? Like one picture with the inertial frame.
yeah, like the thing is, if it's an inertial frame, light's not going to fall. It's just going to go in a straight line. That's where I'm getting confused. You only get that light bending if you're accelerating, I think. Change. Thank you. Welcome in, change and Raiders. We're talking about general relativity. Hey, White Shadow. I hope your stream was good, change. I'm trying to think of like what this experiment would be. Like, I feel like we almost need to negate it in some way. Like we need to do an experiment that's with laboratory that's big or over a long period of time. I think your keyboard would be improved with cream cheese frosting, for sure. Nice change. Glad to hear it.
It kind of feels like the last question we did, right? Number 3, where we had to find out how far the light would fall. Or I forget
Oh
exactly what
yeah.
we had to do. Because
Um,
that was around the Earth, right? We were trying to find out how big the laboratory would have to be for the light to fall like 1 millimeter or something. Is that what the question was?
I think so. Yeah. Art is astronomy. I haven't studied it for myself, but I think it's pretty easy to get introduced to it without having to do anything crazy. But it can get hard if you study it super deeply. Um, where is it? Yeah, number 3. Yeah, how wide does the rocket or elevator have to be for the right rate to fall by 1 millimeter over the course of its transit? Levi-Civita connection? That doesn't sound familiar, no.
No. I think that's later in the book, maybe.
Using only, so they say, like, i.e., using only freely falling and inertial frames.
Yeah, so if we were, a certain distance above the Earth in space or something, and we had 2 frames, one frame just fixed relative to the center of the Earth, and the other one allowed to fall under the gravity of the Earth. I feel like those are the 2 frames we have to consider. And Storm is saying we have to think of a very short amount of time, I guess.
Hmm.
They had an example. It's kind of like, oh, I don't know. I want to say it was like the example in the book with the two ping pong balls in the space shuttle. Maybe that's similar.
Um, I'm trying because like I think this is something I saw in like the World Physics video that I watched where he showed a rock with like a flashlight kind of like built into the wall of it. I'm not getting my stuff mixed up. It wasn't in the book. Um, no, this is Gravity by James Hartle, and I'm wondering if we need like two rockets, one that's just constant velocity, and the other one is accelerating. We like we don't want these to be the same, and the Coulomb principle is saying that they are the same, and that's where I keep getting confused with this. But
Yeah, me too. Weren't you saying trying to come up with a contradiction, like maybe assume the light doesn't fall?
that's like the best thing I can think of. Yeah. Um, hey, Speedcuber, I'm good. How about you? Um, small. Sorry, my ceiling fan is turned on. It's being noisy. I'm gonna turn it off. One second. Okay. Hmm. Okay, Storm is saying something. For an object in the laboratory, what acceleration in the referential of the laboratory? You do the hypothesis at time sufficiently short, you consider the acceleration to be equal to the acceleration in the laboratory. Not sure, Storm. Like we should put like a ball inside each of these. My friend, this is building up to general relativity. Small space is empty space, short time is gravity unchanged. Um,
Yeah, I really don't know how to prove this without, it feels like I don't know how to prove it without like assuming it to begin with.
yeah. I kind of want to at least look at the first part of the book's solution because I don't know I don't know where they're trying to go with this. Would you mind if I did that?
Maybe Storm can. What should we write down first, Storm? Maybe he's got an idea. Yeah, I don't mind if you want to look though.
Okay. Okay, the first sentence was consider a lavatory falling freely and radially downwards in the gravitational field of the Earth.
Newton's second law. He did say weight force versus MA. But how does it apply to light?
Yeah.
Maybe this is this equivalence principle. I think is a really big concept.
Hey, Poison Mouse. Yeah, probably is.
Because I remember Dr. Cook talking about it a couple chapters ago. He referenced this idea, or he mentioned the equivalence principle.
I remember talking about like gravitational and inertial mass. I remember like the equivalence principle piece though. I don't know, or like I don't know what the issue is, Mouse. Like as long as it's like a past exam or something, I don't know what the issue would be. Yes, Storm. It.
Yeah, that would be helpful. I don't think I really understand this equivalence principle.
No, streaming with other people is a great thing, Mouse. Oh, like Zoom works, Discord works if the teacher does that. But Zoom is like the most common thing, and it would get the job done if they don't know Discord.
Maybe we just assume. Let's see. Can we assume if it's the freely falling? Oh, by the way, if it's freely falling, does it matter that if the acceleration is pointing down? Like I was thinking that things falling towards the Earth. I guess you could. I guess it could be nose first towards the Earth, right? The Earth could be at the top of your picture instead of the bottom. That's fine. So when I guess it wouldn't have to have its thrusters on either.
It's Earth that it's accelerating up, not the rocket that's accelerating down, I think.
In your let's see. So let's see if we can agree on this. So if it's an inertial frame, I was thinking of an inertial frame being fixed like at rest with regards to the Earth. I mean, it doesn't have to be, but that's kind of what I was thinking of. So like A equals 0, we could say.
Wait, but the Earth is moving around. Like, it's accelerating. If it's at rest relative to Earth, then the frame would be accelerating.
Well, whatever. Yeah. So assume you got a frame centered at the center of the Earth then, right?
Okay.
So the frame centered at the center of the Earth. And in that frame, we've got our rocket ship that's at rest.
It's still going around the sun, I guess, but I can just go with your train of thought, I guess.
Yeah. Well, anyway, that's not the one I was thinking about. I was thinking about the other one that is freely falling, right? They said it was freely falling. So I was thinking falling would be, you know, falling because of the gravitational field coming from the Earth. So like, you know, falling towards the Earth.
Mm-hmm.
And only under the its own weight force, right?
Right.
Freely falling. Maybe we don't even have to think of a rocket. We could just think of like, you know, you got two balls, you hold them up in your living room, you let go of one of them. The other one's not moving with respect to the room, and the one you let go of is freely falling towards the floor.
Okay.
And so if you were a little ant inside the ball that's freely falling towards the floor, then what can we say about how a light beam would look to you as you fell? As you're in free fall towards the floor, what can we say about what a light ray would look like?
I guess you would see it as
I
being
don't know.
curved.
Is that the way to think about this problem? I'm not sure. Versus if you were, you know, if you were another ant at rest on the other ball that's being held in place. The same light ray passing the two balls, like what does it look like with respect to both of those two frames?
I want to say one would see the light going in a straight line, the other one would see it being curved. But this has been kind of a source of confusion for me.
Yeah, me too. Me too. I don't know if that's that's kind of what I want to say too. I don't know if it's right, but I think that's what I want to say. Yeah, like if you're the ant falling with the ball, you see the light going straight, right? Because you fall as the light falls, right? Is that correct?
Oh,
So in your
I guess so, yeah.
in your frame, you see it going straight.
Or,
Do you remember the problem from mechanics, like Physics 1, where they talk about you're trying to shoot an arrow at a target or throw a rock at a target, but the problem is, as soon as you throw the rock, the target's going to be released and it's going to start falling. Did you ever see that problem?
the target is
I don't know if
I don't think so,
Morin
no.
had it in his book or not. But the interesting thing was that you just aim straight at the target, and then yes, fizz buzz, yes, exactly. And it doesn't matter if the thing is released as you throw your rock. Well, actually, it's good because then they both accelerate down at the same time, and you're guaranteed to hit the target.
Oh.
Yeah, yeah, it was a monkey, wasn't it? You're trying to kill the monkey. I know.
That is rude, yeah.
What do the physics teachers have against monkeys anyway? This kind of feels like that, though. You know, if you're on the frame that's freely falling, the light ray falls with you, so you just see it going. You don't see it. It looks like it's straight, I guess, in your frame, I guess.
Well, okay, but what about the rocket ship, where if your rocket ship is accelerating, the light would enter the rocket at one hole and then leave the hole like lower on the rocket?
Yeah.
Like, it's going to look like a parabola to you. I don't know if it's that.
Yeah, like figure 6.5, right? You're thinking about the third picture there.
Yeah, exactly that.
Ah, so every one of those four pictures in figure 6.5 has a frame that's, well, the first three frames are accelerating upwards, right? And in deep space where there is no gravitational field, the fourth frame is on Earth, and it's not moving with respect to the Earth, but then there's a gravitational field.
Mm-hmm.
Maybe this is the equivalence principle. So let's see. Yes. So now imagine these four pictures, but every one of them add an acceleration vector of g pointing downwards, so that the first three aren't accelerating, but the fourth one is like freely falling, right? I mean, it's not going to be on the surface of the Earth anymore, but it's gonna be in free fall.
You lost me with that last bit. Like,
So let's say we take all four of these rockets. So the first three can stay where they are. The fourth rocket has to be moved up to outer space with the other three, right?
okay.
But now the first three rockets, they turn off their boosters. They're not accelerating anymore. They're going to be sort of stationary with regards to the Earth. But the fourth one's going to be let go, so it's going to be in free fall
Towards the Earth. Okay.
back down towards the Earth. Now, I think in that case, let's see. Wouldn't it be that the first three rockets had a light path that would go? Yeah, the first three rockets would see the light beam curve, but the fourth rocket that's falling with the light would see the light beam going straight.
I feel like there's still the issue where the inertial frame is just different from the accelerating frame. And the equivalence principle says they should be the same. It's over a short enough time.
Yeah, this equivalence principle that he put in the box, I don't really understand. I like what Hamiltonian dynamics says in chat. I think I did read that somewhere. So you can't tell the difference between being in an accelerating frame versus being in a gravitational field.
Enigma, thank you for fixing the bot. Um, so I feel like the book already only used freely falling frames to explain why light falls in the gravitational field of the Earth. Why would we include an inertial frame here? I'm going to peek a little bit more at the solution, I think. So I feel like
Okay.
I don't know.
Yeah, I don't know either.
I feel like the book has some kind of point they want to make here, but it's kind of just a little bit lost on me. They consider an inertial frame in which the center of the Earth is approximately at rest. So, like, I guess a short enough time. Laboratory is falling with a local acceleration of gravity. Light ray transits the laboratory at a certain height above the floor. In laboratory, the empty space light ray would move straight across the lab and exit at the same height. The case in the freely falling lab, only if the light ray falls with the same acceleration as the lab. Oh, it's the entire answer.
Oh, so actually, wait a second. So you know what? The inertial frame should have been way, 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 way out in space where there was no Earth. Is that what we were supposed to do? Let me see. Yeah, so the first three rockets should have been moved far out in space where there was no Earth. No mass anywhere around, I guess. Hey, you know what was cool this week, Don? I started reading a book, Tristan Needham. It's Differential Geometry.
Oh, I've heard of that. Yeah.
Yeah, and in chapter 3, 4, maybe chapter 4, I forget which chapter, but he's talking, maybe even chapter 2 or 3, he's talking about geodesics.
Oh, wow. I think that's a chapter or two away for us. Yeah,
Yeah.
2 chapters.
Yeah, that was cool. So I've got a little more of an idea of what that might be.
Awesome. So I think you did say the big idea at one point, which is the lab is falling at the same rate as the light ray falls.
Yeah, freely
So it
falling,
does look
right?
like a straight
That's
line.
what that has to mean. Freely falling, it means in a gravitational field, I think. So under its own weight force. Something falling under its own weight force.
Okay, so where I was getting mixed up with figure 6.5 with the rocket is they do it with a wide enough laboratory over a long enough time. But if you make it small and short, it does have to look like the inertial frame. Okay.
And the other problem with 6.5 is I don't think any of those frames really were inertial. Or no, that's not true, is it? Maybe the fourth one was, but the first three weren't because they were all accelerating.
No, I think Earth is not an inertial frame. So if it's just at rest on Earth, you can cheat it by saying over a very short period of time, it's approximately inertial.
Yeah.
But FizzBuzz, I would have considered something like the NASA plane that lets you be in free fall for like 30 seconds. You would see the laser traveling in a straight line inside that plane because you're falling at the same rate as the light. Okay.
Yeah, Hamiltonian dynamics. I want to say the first three parts are the same frame, I think, aren't they? I think all three of those are kind of the same picture. I might
it's the
be wrong
same.
about that.
Oh, I guess they're different frames. One is an inertial observer seeing the light ray enter the top one. The second one is an inertial observer seeing it leave the bottom one, which are probably different observers. Okay, fair FizzBuzz. Okay. Um, that was kind of tricky.
Well, it was tricky. What's the so what's the reason behind this sufficiently short time? Why does it say over a sufficiently short time?
Because
A
gravity needs to be
sufficiently small.
about uniform for us to get this clean version of the result, I guess.
I think, yeah. Storm said something about that in the chat. A small space means like empty space, and a short time means gravity doesn't change.
That also makes it, I think, closer to being an inertial frame, like approximately inertial, I guess. So you can accelerate, or you can't accelerate as much in a short time.
If I keep doing physics, I think one day I'm going to understand what an inertial frame is.
I feel like I understood it first, but I feel like I've forgotten it now or something. Okay, are you ready for the next one?
Yeah, okay, let's try
Okay.
another one.
Um, this one seemed a bit more computational. Transform the line element of special relativity from the usual tx by z rectangular coordinates to new coordinates t prime, x prime, y prime, z prime, related by those, for constant g with the dimensions of acceleration. And so I didn't get a screenshot of it, but I think the line element they're referring to is ds squared equals minus dt squared. Yeah.
Yeah, okay.
So we're going to need some derivatives here.
Yeah.
So dt is going to be equal to product rule. Dx prime over c sinh plus, oh wait, ugh, this isn't c equals 1. Why do they do this? I wish they would just stick to c equals 1 or not c equals 1 and stop playing with me like this.
Oh, that's right. Didn't they say in this chapter c is not equal to 1?
Yeah.
Yeah.
Hey, Chinmoy. Derivative of sinh, that's just, is that positive, Kosh?
Yeah.
Okay. All right, I think it's our dt. I assume this is going to get cleaned up by some hyperbolic trig identities. Okay. So doing derivative of the x piece first. We're going to get just a dx prime cosh gt prime over c. Plus cosh. Oh, is that still positive sinh?
Yeah.
Okay. Apparently I'm slowly learning these.
Okay, nice.
All right. I guess we're gonna plug these in and cross our fingers. Are there any cancellations that we can get our not that I see. Just like within the dt and dx here, but
I don't know. I don't see anything.
I don't think we will. Okay, so I guess I'm taking a c squared.
Should we
this is
bring
gonna
the
be so
c's
annoying
over?
with squares.
Like you could bring this c over and this c over maybe and put it here.
Oh, like on the very outside? Yeah.
Maybe. Is that a good idea? I don't know. Maybe.
I think so. It'll give us a bit less work. Because we'll have CDT there and CDT there. That's actually like that. And I'm chopping off that over C there.
Okay.
So then we get dx prime gt prime over C plus. It's going to be annoying to square.
Maybe we can bring this G into here.
Oh, inside the... Yeah, we could do that. Delete that, delete that, delete that. Bring the C down, and then put a G. That's supposed to be... Did I just randomly made that x squared when it's supposed to be a prime.
Oh, good catch.
Okay.
Yeah, because you know what? It looks like we want to keep everything in terms of either G over C or C over G, right? Like everything, they're always going together, these things.
It seems like it, yeah. Dx prime. Gosh. GT C. C over G plus x prime over C. Cinch. Oh, we have a G over C out front there.
Yeah, those C's could cancel, couldn't they?
Yeah.
That is something could cancel. This one with this
And
one.
we can bring the G inside again.
Yeah.
Then put dt prime out front. GT prime over C squared. And then we need y prime and z prime. Those aren't that important. Hey, AL cool. Okay, now for the painful part of squaring these. Yeah, I guess we just have to deal with that. I was reading the question to see if there's a way around it.
Yeah, look, all the cross terms are going to cancel, aren't they? This is nice. I think this is going to come out nicely.
Okay. I assume they wouldn't give us something that's just gonna not cancel. Be a little
Yeah,
mean.
because if you look at so basically they're just both big binomials being squared out, right? Like this times this, or this plus this squared, and this plus this squared. And the first are going to give us something with dx's, and the second will give us something with dt's. Sorry, I'm writing on this.
Oh yeah, like I'd rather just not write the cross terms if we can agree that they cancel.
It's because of this negative at the very front on the first one that gets squared, right? I think. Do we agree that because everything matches up? We got cinches, we got coaches, we got dt's, we got dx's, and we got this c plus gx over c thing.
Okay, yeah, that's going to cancel.
Nice.
Okay. So I'm not going to bother writing the cross terms at all in that case.
What's shine plus cosh though? Oh no, we got a minus. Oh, I think we're in business.
Yeah, that's just going to be Pythagorean or whatever it's called for hyperbolic. Trig. Sage, you passed your final? Congrats. Dx prime squared, cosh squared, gt prime over c plus gx prime over c squared. Oops. Sinh squared gt prime over c. Don't forget the dt prime squared. Okay, Lana PB, thank you for the follow. All right, and then our DXs, we get a negative cinch and a positive cosh. Oh, thank you for writing that out. So cosh minus cinch is 1.
Yeah.
And so we do have a cosh minus cinch here. And so I guess that's just dx prime
squared.
Yeah, squared. And then we have a minus cosh and a plus cinch with a factor out front. So it's going to be a -1.
Yeah.
Oh, this is dx squared. I should put time in front. So it's going to be negative in front. The c plus g x prime over c squared dt prime squared. Just verifying. I think that's okay.
Yeah.
Okay.
Maybe we want to factor out no. I'm trying to make it look like what they gave us originally. If we factored out a g, we could get it as c over g plus x prime over c. I don't know if there's any advantage to that. I think it looks good.
Yeah. Maybe the later questions are going to inform us on what we should do, but I assume that they're going to make us figure out the meaning of this type of transform because it comes out cleanly. But why?
Yeah.
Okay, so part B says for GT prime over C much less than 1, show this corresponds to a transformation to a uniformly accelerated frame in Newtonian mechanics. GT prime over C. Wait, we have a GX prime over C. Okay, well, I think in chapter 5, they used Lenovo for special relativity and got the second derivative equaling 0 as a demonstration of Newton's first law. Maybe they want us to do the same thing here, but we'll get it's equal to a constant. Hamiltonian dynamics is the same.
No.
Look at the
Chapter
coordinate
5.
transform.
Oh no.
Oh, maybe that we do have a GT prime over C there, yeah. Or yeah, I assume cinch is just going to be 0 and cosh is going to be 1. Maybe it was chapter 4. But they somehow used the line element to demonstrate Newton's law. Newton's first law.
Yeah, I don't remember that. Where did they do that? Oh, Hamiltonian dynamics. You're saying we should go back to the definitions in terms of cinch and cosh, right? And expand those.
Um,
Yeah, because if they're saying this is much less than 1, then that's the argument to our hyperbolic functions there.
yeah, I guess that's probably a more worthwhile thing to try. So sinh of basically 0, I believe, is 0. Um,
How many terms do we have to keep?
well, Haley hate. Pickled herring. I don't think I know the reference. Um, what's oh I wait, no, the Taylor series. I remember from Complex. The it's just sign that's not alternating.
Oh yeah, it's like sine, but no. Thank you. It is.
N equals, I think, 0 to infinity, x to the 2n. Ooh, I think,
Good. Yeah, good. I like it.
is that, it starts from 1 though, and I'm starting from x, right?
Yeah, no, you're good. You're good. If you plug in 0, you'll get x to the 1 over 1. So
Oh,
that's
duh,
good, I
yeah.
think.
Okay.
Yeah.
Oh, cream cheese frosting. No, I maintain that it would improve that. Enjoy the daisy though. I don't think it'd be good. I'm just saying it'd improve it. Okay, so if I assume we like, can we just keep the first like even 2 terms, let's say?
Okay.
But even then, right, it's cubed and it's much less than 1. I feel like we could just wait. Isn't of x about x?
Yeah.
That
Yeah. Because it comes through the origin
oh
at 45 degrees, I think.
oh
The
yeah.
graph of it.
Okay. See ya, Kaylee. Thanks for saying hi. Okay. I that would mean that we just say 0 though. Hinders nice streak. Thank you, Sat Week. Huh. That feels weird. Banished. I'm not making that my name. Because like, if I'm the thing that I want to do, and I'm saying that time is 0, because since it will be 0, and that x would be
Oh, wait a second. Wait a second. Yeah. Because we got, so now we got to let x equal gt prime over c, right?
yeah, exactly.
Okay. Okay. Yeah. Yep.
Like I'm just saying that since of like the since factor is going to be about 0, and the cosh factor is about 1. Yeah, famished. Hey Raven. Yeah. New name.
Well, no, I don't think t will be 0, will it? I mean, we're not plugging in 0. We're plugging in x now. We're plugging in gt prime over c, I think.
I will, but it's much less than 1, is why I was saying that. I guess maybe we should keep the first order.
I say keep the first term, I guess.
Okay, fair enough. That'll probably give us an answer that actually makes sense, hopefully.
Yeah, because if we distribute that through, I think we're going to get something that looks a lot more familiar.
C over G plus X prime over C. Oh, yeah, what am I saying? Sinh of X is about
Yeah.
X. Okay, got it, yeah. GT prime over C.
So what does that give us? T prime plus something. G over C squared, X prime, T prime.
G X prime T prime over C squared. Okay, that exists.
Maybe we should factor out the T prime and like 1 plus G over C squared X prime.
Oh, maybe.
I'm trying to make sense of what this is telling us.
Nice famished. Oh, for X, we get just X prime, I think. Oh, is this gonna be no. Let's say, what if it's gamma or something? It almost looks like a Lorentz boost.
X equals X prime. Oh, so X equals X prime, Y equals Y prime, Z equals Z prime. So nothing happened with the space, but something happened with the time.
Yeah.
Oh.
If well,
They're saying it corresponds to a transformation to a uniformly accelerated frame in Newtonian mechanics.
our measure of time depends on position. That feels acceleration-ish. Newtonian dynamics wants to keep more terms for X.
Oh. Yeah, maybe we should.
Okay. Hey, keywords. I want to be lazy. For X. Okay. 1 plus GT prime over C. Oops, oh my god. Square over 2. That will be the next term for Koch.
Okay.
Minus C squared over G.
Boy, that looks messy.
Yeah. So we still get a cancellation with the C squared over G's.
Okay.
We're gonna get an X prime times a 1, so we get an X prime there. We get a C over G times that times C. That's C squared over G times G squared T prime squared over C squared.
Oh, that still tidies up nice, doesn't it?
Sorta, yeah.
And is there one more term?
Yeah. I'm trying to figure
X prime
yeah.
times that business.
X prime over C.
I think the C will cancel. What I mean is this C over here was going to wipe this one out.
Yes. Yeah, thank you. That's what I get for doing too much mental math. I think that's everything.
Oh, yeah, okay. So we got a 1/2 T squared. 1/2 T prime squared.
G prime squared, right?
Oh, yep. G, yep.
Those are definitely letters and numbers. Assume x prime is small also?
One half AT squared. It kind of looks like one half AT squared.
Oh, yeah, yeah. Oh, that's why Hamiltonian dynamics is saying that. So it looks like the projectile motion. That would be convenient for sure. That would give us something that is very familiar.
Oh, you're saying X prime is small.
They never tell us to do that, but that would give us the exact thing that we want.
Yeah, that's it, isn't it? I mean, that would be what you'd see if your whole frame was accelerating in the X direction. With acceleration G, I guess.
Yeah. Okay.
A uniformly accelerated frame.
I I hope that's what they mean for B. We can check the answer after.
Yeah.
For C, show a clock at rest in this frame, x prime equals h. Runs fast compared to a clock at rest, x prime equals 0 by a factor of 1 plus gh over c squared. Do we already
This is
have that
just
in our
like that.
time? Oh, what?
Sorry.
Or
I was going to say
yeah.
this is just like that example in the book where they had Alice and Bob, and she was dropping nickels down to him or something, but the whole thing was accelerating, and he was catching the nickels faster than she was dropping them,
Oh, yeah.
like at a faster rate than she was dropping them.
Yeah.
I don't know why I said dropping nickels. That's just how I thought of the problem. It's like she's up there dropping pennies and he's catching them, and it's like, yeah.
Yeah, I hadn't thought of it so physically. Like I was just following along with the book's like laser thing, but I guess it would also be true for pennies, yeah. So I think it would. So I think we already for C, I think we already got it for what we did for T without the approximation. Like we have a gx prime over c squared.
Okay, so you're saying X prime equals H now. Are you saying let X prime equal H right there?
Yeah, and what we
Yeah.
found for T.
Yeah, I mean, it's right there, isn't it? So that would say T equals T prime times 1 plus GH over C squared. Yeah, you already got it. Okay.
Hamiltonian dynamics saying we can use the line element for part C. Uh, oh, I guess the same factor shows up there too. If we presumably factor out
Oh,
a
yeah,
C.
there it is. Yep. Yeah, from part A, right? The first term there.
Yeah.
We'd factor out a c, is it? I guess that makes sense because it's like c dt squared times 1 plus gx prime over c squared.
Yeah, like gx prime over c squared squared c dt prime squared plus da, da, da.
Yeah.
Hey, Phobos. And since it's at
Phobos, hi.
rest, everything else is 0. Okay. How's it related to the equivalence?
I feel pretty good about this one.
Well, we saw the part 2 for C, which is the equivalence principle.
What'd you say? Part 2 for what?
Well, C asks how it's related to the equivalence principle idea.
Oh yeah.
Our old friend / nemesis. Oh, well, I mean, that's just, well, no. I guess that just looks like the time dilation of special relativity.
Yeah, that's what I was about to say. It's a special relativity idea, isn't it?
Like it's just a constant if it's at rest instantaneously like that. So it's calculated differently, but it's basically gamma.
Actually, Don, your microphone's cutting out on me again a little bit
No.
today. Is it? Did you turn it down or something?
I haven't messed with it. I have no clue why it's doing that.
I wonder if it's an automatic. How does Discord work? Like, how do you choose your volume level on Discord? Is it automatic? Is it just automatic? And then, but I know you can tinker with it too.
Yeah, there's like an input volume thing. Mine is all the way up.
Oh, is it? Okay. Yeah, no
Um,
worries. I'm getting like at least 90% of what you say.
all right, I'm sorry. Oh wait. I wonder if it's the noise suppression. I'll try changing that. Because I remember messing with the audio gate before and that didn't help. So maybe it's that. Okay. Well, I just changed the noise suppression thing, so hopefully that helps.
Okay.
Um, so 50-year speedrunner now? Nice. What game? Okay, I guess, should we check the answer on this?
Did we finish part C?
I think so. Or, like, yeah, I think saying that it looks like special relativity for a short enough time is the idea that they wanted. I hope at least. Okay.
And Hamiltonian dynamics says clocks and gravitational fields also have time dilation. You know, they did say that in the chapter too, didn't they? They were talking about the campus at UCLA or wherever the guy's from, and they said
Oh,
the physicists on the second floor have a nicer view, but they said if they work there for 30 years, they're like three thousandths of a second older or something because they were on the second floor the whole time.
right, yeah. Small price to pay for a view, they said.
Yeah, that's right. That's what they said. Yep.
Yeah, I found it. UCSB, Santa Barbara.
UCSB. Okay.
All right, I'm looking at the answer.
Okay.
Let's see. They gloss over all the messy squaring and stuff, but we do get to the correct line element. Looks like. Oops.
Nice. They even factored out the c squared like you just did.
Oh, but they did d tau squared, but they didn't negate the other stuff. I hate that. The time part is still negative, even though they said tau.
Yeah, why is that d tau squared instead of ds squared?
Yeah, I thought this is ds squared, and d tau squared is the negative divided by c squared. I don't know. Hey, Ashwin. Yeah, I would guess the typo too. I get Hamiltonian dynamics. For part B.
T is approximately t prime.
Yeah.
X is approximately x prime plus 1/2 gt squared. Okay.
Ooh, so we. Whoa. We didn't get that exact thing.
Didn't we? I think we did.
We don't have the x prime plus. We only had the 1/2 gt squared.
Oh, I guess we should have kept the x prime, right? I mean, we were assuming x prime was small, but we couldn't just throw it out.
Yeah, we can throw the one that's multiplied, but not the one that's added, I guess.
Yeah, I hadn't seen that, but we probably should keep that, I guess.
Huh. I don't know how we're supposed to figure out the x prime being small thing. I feel like they're just gonna tack that on.
Yeah, I mean, the question didn't say anything about that, right?
Yeah. No. Oh well.
What about part C? Did we get part C right?
Um.
Yeah, you know what I think they're doing, and this is what I thought we were going to have to do. I think they're using the formula that they came up with on page 117. You remember that one with the difference of the rates? The ratio between the rates emitted and the rates received is like 1 plus the difference in potential over c squared. I thought we were going to have to do that.
Oh.
Maybe we didn't have to because it just, yeah, this one right there, 612, yeah.
But that's not for clocks, though, right? Or no, well, I guess it kind of is.
I guess it works for clocks.
Because clock, like, their version of a clock is like light bouncing between two mirrors, which would have this emission reception thing going on.
I'm marking that one up as a win.
Yeah, I'm a little weirded out by what exactly they're doing here.
It feels like they've got, so the first line there is for Alice, right? And the second line there is for Bob, isn't it? Or vice versa, maybe.
They're dividing the same proper time at different x's.
Yeah, if you look at those, let's see, look at those three equations. They look exactly like, where did they do this in the chapter here? Yeah, page 128. The very top of page 128.
Um, hey, Daksh. Very top of page 128.
Yeah, there's three equations, and it's sort of like the three equations in that.
Oh yeah, those do look really similar.
Yeah,
Okay.
I think that's what they did.
Hmm. Oh yeah, okay. I yeah. I think I get what you're saying with like, yeah, we're evaluating at different points. This whole part, like, it was super cool what they were doing in this part of the book, but it's so weird. It takes a lot of getting used to.
I know. I feel like I'm probably catching about like 30% of what's going on in this book.
Yeah, same.
I mean, it's a good start. It's whatever. It's a good start.
Yeah, I definitely don't expect to become an expert by the end of this. Okay. Um, the next one I have actually relies on number 6.
Mm.
It's number 7. I brought it in at the bottom here. Hey, Kayla. How's it going? The start of the laboratory has a bottom at x prime equals 0 and a top at x prime equals h, both with extent in the y prime and z prime direction. Use line element derived in part A of problem 6 to show the height of the laboratory remains constant in time. The laboratory moves rigidly.
Oh, so we assume it's accelerating. Oh, wait a second now. And the problem we just did, the acceleration was in the x direction, wasn't it?
Uh, yes. It's going good too, Kayla. Thanks for asking.
Now they're saying our laboratory has the bottom at 0 and the top at x equals h. Oh, sorry. The height remains constant. Oh, I thought they were saying that. I thought they meant that the top would stay at the same place. No, no, no. They're saying the height of it remains constant. Okay.
Okay, so maybe we need um, a diagram here, like a space-time diagram.
Okay.
So we want to evaluate, we have x prime equals 0 and x prime equals h. Oh, I guess these are all primed. 0 and h.
Nice.
So the height of the laboratory remains constant in time. Like I say, well,
Well, wait a second, but the green lines won't be vertical, will they? They'll be.
no, they won't necessarily be vertical.
Oh, wait, but you're in the prime frame, so maybe in the prime frame they are vertical.
Yeah, like I don't know how I did just make a big assumption by drawing the lines how I did, but I think the goal is to show this horizontal distance is the same at any time.
Yeah.
Hey, Sladarth, yeah. Oh, I feel like we need an integral from like some generic a to b or something. Generic like integral from a to b. Uh, and hopefully get a constant at the end of it. Oopa, hey dude. Yeah, name change. Hope you're doing well. So I thought I had a panel that does that, but I'm most comfortable with like first year undergrad like calculus and below. I can do some linear algebra, some differential equations and stuff. Oh, awesome, Kukuba. I'm glad.
Should we
Hmm.
should we hit this with another horizontal line like this, and like try and show that at some later time, let's say?
That we show it's a later time, a horizontal line.
Well, I mean, pick any arbitrary later time, because this is for t equals 0, right? That's where these initial points were.
Yeah.
T prime equals 0, I mean.
That's when I'm on Windows.
What does this factor here tell us in this line element? Is this some kind of a slope? I mean, should these lines be going up at some slope? Yeah, maybe they should.
Oh,
How about this, Don? If we set ds to 0, right? If we set it equal to 0 on purpose and we solve for like the ratio of dx to dt, couldn't we find the, the slope of these lines maybe?
if ds equals 0, aren't we moving at the speed of light?
Yeah. Hmm. That's probably not right.
It works.
I'm just trying to think of what would it mean if
And we could do like a ds
oh
less than 0 would be time like.
oh is it? We want to be less than 0. Yeah, okay. You know what? I'll bet you because we had quotient sinh, I'll bet you these things are going to go up like this maybe, right? Like along hyperbolas, maybe?
Could be, yeah.
But regardless of what they look like, I bet you we need to show that some horizontal line will the distance between those two curves will stay at h maybe.
Yeah. Um,
What if we went back up to the transformation equations from question 6? And if we could try and just derive the equation of a hyperbola from those, would that be helpful?
Hmm.
If you look at those equations, I can see, you know, if we could get x squared plus t squared in some, or x plus, yeah, is this a good idea? If you take that second equation and you add c squared over g to the left side with the x, and then divide the c as well. Anyway, we can get cos squared and sine squared there, right? And maybe we can get a hyperbolic equation between x and t.
Well, x and x prime don't mix, right? Or we've got too many unknowns. Were you saying there'd be like a cancellation there?
Uh,
I don't think anything would cancel, but we would get a weird like ratio.
yeah.
I kind of feel like it's maybe something simple like dt prime equals 0, dy prime and dz prime also equals 0, and just the distance between, with this line element, the distance between two things only separated in the x direction does not depend on time. Like that argument almost feels too simple, but like I guess you'd say the bottom and the top laboratory are space-like separated. And if we had, for it to not be constant in time, we would need some like the dx prime squared need to be multiplied by like a t prime or something like that. But we don't have that, so it's just, it moves rigidly. Just have to like use the line element. So I'm trying to figure out like, I guess how we do that.
Yeah.
I don't know, I kind of like the argument that I just made. I don't see what's wrong with it. I wonder if it's too, if they want us to actually do some type of calculation, but
Is there any way we can use part C from the last question? Because that's where they were talking about clocks, you know, clock at x prime equals h versus clock at x prime equals 0. So that'd be like if we had a clock on the floor of the laboratory and a clock on the ceiling of the laboratory.
Uh, they would measure different times, right? Because we're accelerating.
Yeah.
And that's probably a good thing. I don't know, but they found that result with a different, with like a static weak field metric. I don't know.
Hmm. Oh yeah. What if we look at that static weak field metric equation? Is that helpful?
Well, I think we have a different metric is the issue. Like that's what they use to find that a gravitational field affects clocks. But we have a different thing that we're starting with. Hmm.
Oh, part B's got a dot product in it,
Yeah, I've been eyeballing that one a little bit too.
which makes me think of the dreaded chapter 5.
Hmm. The only thing I think of to do here is to try to set up some type of integral and hope whatever result we get doesn't depend. I guess it doesn't depend on time. I don't know like what to integrate over though.
Yeah.
I guess you'd want to integrate it in time. How would this work? I guess we would know this is dx prime dt prime is acceleration. Or no, sorry, that's just velocity. But we know the velocity is acceleration times time. Uh, but x is a function of time also. This might be all sorts of terrible, but This. Although I guess I already got rid of all the x's. Or what am I hoping for if I do this? I don't know. I've kind of lost the thread here. Oh, the c squared. Yeah.
Well, this looks like it might be, I don't know. At least it looks like math now. I mean, we got a shot, right?
Yeah. It sure does. It could be some nasty arctan suburb or tan suburb though. Completing the square. You know what? I want to bring the c squared back inside.
Yeah, it looks good.
Just to make this next bit a little bit easier. You know, I can't. No, this is too much for me to do in my head. I need to resolve this.
Okay.
1/4 g squared over c t prime squared squared. Wait,
that's
no,
still
no.
One half, right?
Yeah, I added too many parentheses. 1/2 g squared over c t prime squared. Okay. I feel like I don't have a good feeling about this.
No, I know. I wonder if I mean, it seemed good until the C's weren't playing nice. I wonder if we need a C in this other term here somehow. I don't think so.
It's going to cancel because we get a minus g squared t prime squared from this factoring.
Oh, beautiful. Well, now I'm much happier again.
I'm much less happy seeing that we're going to have to integrate basically 1 plus x to the fourth, or 1 minus x to the fourth. Wait, isn't this just a negative number? We have too many negatives. No, this can't be right. At least not. I mean, maybe I should have integrated proper time or something instead. Actually, I almost definitely should have done that. But there's no
What
way
do
they
you
want us
think's
to do
wrong with
this
it?
integral. I think I needed to negate the line element and make it more like proper time.
Oh.
Because I have a minus c squared and a minus. It's just the square root of a negative number here.
Yeah.
But even if we negate it, that integral looks a little bit difficult. I mean, they may say just like Taylor, just hit it with a Taylor series or something and forget about it, but I know I don't really know what to expect at the end of this. I don't know what means that we've succeeded. I guess that there's no dependence on x prime, but I already kind of got rid of that by doing the substitutions that I did.
Yeah.
So I don't know. I think this might be another more. I just want to see the first sentence of the solution.
All right.
Okay. The line element shown in part A of the solution is independent of t prime. Oh. I think it's the first thing that I was saying. That the line element is independent of t prime, so the spatial distance delta x prime between two curves of constant x prime remains constant in t prime. So they're saying because t prime doesn't appear anywhere in the line element. I said it's solely because of the dx prime piece, but maybe it needs to be nowhere.
Oh, yeah, that is what you said. What did you write there? No dependence on t prime.
Yeah, I mean, I meant specifically for just the dx prime piece, but it's not like they're saying the entire piece.
So they're saying our line element doesn't have any t prime in it, and therefore it can't depend on t prime.
Yes. I want to get rid of this integral.
So we didn't have to do any math.
I don't think so. Let me see if there's more to this solution. No, okay. That's the entire solution for part A. Okay, so we were making it harder than it needed it to be.
All right, well, you got it right then.
I guess so. Compute the invariant acceleration. A dot A to the 1/2. Where A alpha is the second derivative of each component in proper time. Show it's different for the top and bottom laboratory. That feels weird if it's going to be different, but okay. How does this is like a chapter 5 thing.
Yeah.
So maybe we need to, A is going to be du d tau. Wait, they're saying, oh wait, maybe, Shooting, we're thinking of it as like function time of tau and x of tau. Like maybe the functions we got in number 6 is where they want us to go with this.
Maybe.
Oh, they don't say to use. I wish they would tell us what they want us to use it here, I guess.
Is there a way to get from a line element to an acceleration vector?
That's what I want to do based off what they had us just think about.
Maybe this is the acceleration here in front of our. Yeah, when we had flat space time, this was just a 1, wasn't it?
Yeah.
There was like a 1 here and a 1 here and a 1 here and this was just a 1.
Mm-hmm.
This expression here has to have something to do with the acceleration, I think.
Yeah. Hey, ND Vines.
But how to write it as a 4 vector, I got no idea. I guess we don't have to. We're just trying to find lowercase a, right? Or italic a.
Yeah. We need to find separate equations for each of these in terms of tau, I think, but I don't really know how to even start that.
Yeah, how did they write this? They did something like, a t prime, a x prime, a y prime, a z prime.
Yeah, and they're doing like chain rule tricks where like dx or dx d tau is dx dt times dt d tau, and like
Okay, so yeah, that's vaguely familiar. And what was tau again? Proper time, which was ds
minus ds squared over c squared.
d tau squared is minus ds squared over c squared.
Hey Matthew, just because it looks like on an exclamation point. Do we take t equals tau and say x equals 1/2 g tau squared?
Well, we could try it.
Actually, I'm considering. I wonder if we need like, like the factor in front of the dt prime squared that you were talking about,
Which factor? Oh, yeah.
like the 1 plus gx prime.
Yeah.
Actually, yeah, and the thing that I said, it wouldn't give us different accelerations for the top and bottom laboratory.
Really?
Well, I mean, I'm just kind of going to regular like Newtonian. Like, if we're just gonna take, like, we just get constant acceleration. For like a projectile falling in a, or just like projectile motion, everything falls at the same acceleration. We're supposed to get different accelerations though.
Yeah. Well, from question 6, part C, we know that the clocks are going at a different rate. by a factor of 1 plus gh over c squared. So does that somehow explain why they would have different accelerations?
Probably, yeah. Um, a similar where I don't know how to start.
I know. I got to throw a lifeline out on this one.
Um, yeah, I mean, the difference in acceleration is probably going to be from the time component, I guess. I don't know. It's might be another one where I just peek at the first sentence of the answer.
Yeah, I got no problem with it if you want to.
Okay. Okay, so the forward velocity in the tx frame can be calculated from the expression xt prime yt prime in problem 6.
Oh, to get the forward velocity.
Hey, Sarthak and Josh, less deconcentrated, no worries. Enjoyed the cookout. So I didn't realize we have to calculate it in the tx frame. That there is no prime in that, is there? Oh my god, that makes this so much easier. Or that I feel like, okay. Oops.
You get it? I don't get it.
So um from number 6, we had, I guess we're using t is about t prime. Or like
Yeah.
I never realized, but they're not asking about x prime, they're asking about x. And so we can actually use the equations that go between the prime and the unprime. I think that's why I was thinking that it seems a lot easier.
Oh, you're saying question 7, part B is not in the prime frame, it's in the unprime frame.
Yeah.
Oh.
Um
Really?
I mean, I just don't see a prime on that. In
Yeah.
part B.
No, I
So
agree. I agree.
okay. So this is just, well, okay, but I guess and then I think we just take two derivatives. Oh wait, but we need to worry about, we're taking the derivative in proper time. Uh, and so it's not going to be exactly like, I think we need to modify, we need to sub out t prime for something involving proper time, I want to say. Oh, maybe this is where we do it. Hey, Maple Leaf. Uh, so, and 6 part C, the part that I was confused on, where they were kind of getting the proper time for different heights, one with x prime equals 0, the other one with x prime equals h. I wonder if we have to use those same two different things here.
Oh.
Like we do one for the bottom laboratory and another one for the top and get different results. Um, trying to figure out how to put this all together though. So d tau when x prime equals 0 is just dt. But d tau when x prime equals h, that's where the 1 plus gh over 2 comes in. Sorry, not 2, c squared. I guess these are primes, but it's on the most important piece. And I assume we can integrate each side relatively safely and say, in this situation, in the top equation, we get tau equals t prime, and then the next situation we get, I don't know if we want to even do this, but I think like these equations are how we can get functions of t and x in terms of tau. So in the x prime equals 0 world, our equation for time is t, our equation for time is t equals tau, and then the position we're going to get x equals 1/2 g, and then plus gh over c squared times time squared. Tau. Wait. No, I'm doing this substitution wrong. Ugh. We have t, which is about t prime. Okay, so that t up there is tau divided by 1 plus gh over c squared, and then squared on the outside. Wait, why am I using... No, I'm using two different... I'm doing this terribly. Okay, if x prime equals 0, I think that's what we get. T just equals tau. But then if x prime... And we would take two derivatives of this with respect to tau. Then in the x prime equals h world, I think we still have... No, we now have t is equal to tau divided by 1 plus gh over c squared. Just rearranging this equation.
Okay.
And then x would equal 1/2 g tau over 1 plus gh over c squared.
Plus h, maybe?
Oh, yes, thank you. It'll disappear anyway, but yeah, that's true. Okay.
Oh. Hey,
So,
I like this. I like this.
Okay. I'm glad, because I hope that this is right.
I could have sat here all night. I wasn't going to come up with this, but I like this.
It's g. We take two tau derivatives. Thank you, Grey Wolf. Over in the other situation, the second derivative is going to be 0
So
again.
basically, you got two different frames here, right? Like this is the bottom and this is the top.
Yeah, I wouldn't say it's all the same frame, but different
All the same.
points
Okay.
in the
Two
frame.
different. Yeah. Okay. Yep.
Okay, this is the more complicated derivative.
Yeah.
Actually, I guess it'll be g over 1 plus gh over c squared.
Wow, this is nice. I like this.
So how do these two numbers, like 1 plus GH over C squared, I assume it's going to just be slightly more than 1.
Is this right? Let's just check this. I just want to check this.
Oh, yeah.
The second derivative, right? Don't I need a squared down here?
Ooh. Yeah. I forgot to distribute that squared. Hey, Everton.
Okay.
3289, bunch of numbers. Thank you for the follow. So I don't know.
So the roof is accelerating
slightly
at
slower?
a different rate than because this is like over 1.
Yeah. Does that make sense if it's slower? How's it
Okay, and
moving rigidly, but
H was
not the same?
if H was 0 here, this would turn into the same as this. So that's cool.
Oh, yeah.
And I guess 1 plus GH over C squared when you square it is pretty small number, right? Oh, wait. Well, it's close to 1. So it's basically 1.1 plus a delta, basically.
Mm-hmm. So wouldn't this mean that the laboratory is slowly getting slanted? Like the top is moving slower than the bottom. So like it'll start out as just a box, but as time goes on, actually, I guess if it's accelerating downwards, no. Oh wait, is it getting longer? I'm getting confused with the dimensions. The bottom is accelerating faster than the top. So if it's accelerating downwards like that, it's gonna be getting longer. But still somehow moving rigidly from part A? Is that like a gravitational Lorentz contraction? Sorry, what?
I was just checking. Yeah, so the top is going to be accelerating slower, right?
Yeah.
So you're saying it's getting compressed.
If the top is moving slower, I think it's getting longer. It's gonna be stretched.
No, I guess it depends which way we're accelerating. I thought we were accelerating to the right, like towards the top.
I mean, we're accelerating in X, and then whatever stretching or compression would happen in the same direction. I think.
So how can we?
Sorry.
But in part A it said the laboratory moves rigidly.
Yeah, that's what I don't. So that's why I wonder if it's like a Lorentz contraction but with gravity.
Yeah, maybe it's because the clocks are keeping different time, right? Is that how we explain it? So
I don't know.
Maybe it's because the clocks are keeping different time. So if you like look at where clock A is and look at where clock B is when it says the same time as what clock A said, maybe then they'd be the same distance. I don't know.
It could be. We're a bit past the 2 hour mark anyway, so do you just want to check the full answer now? Are you okay with that?
Yeah. Did we finish? So what's our answer for what A is then?
When we got the different results for d squared x over d tau squared.
Yeah. So basically we got 2 different accelerations here.
Yeah. Oh, I just realized I mislabeled. looks like a T, but it's supposed to be an X.
And we didn't have to find d squared y or d squared z because those are just 0,
Right.
no matter what.
Yes.
Yeah, okay. I think we're done.
Okay.
Yeah, that was hard. That was hard. I didn't know what to do. I had no idea.
Oh, I see cautious and cinches.
Uh-oh.
What? Wait, maybe we end up with a similar looking result though?
Where'd they get the caution cinch? Did they go back to question 6?
I
Oh,
think
they
from
are
the
going back to 6.
yeah, maybe I messed up.
Well, I had thought about going back to question 6 to do part A, but I didn't think about it for part B.
I wonder if we did, because actually I think we get the same. I feel like
Yeah,
we
what'd
got
you
the
get?
same
You got
result
G over
because
G over 1 plus GX prime over C squared. Yeah, you. Oh,
we,
now
we
wait,
just
there is
plugged
no.
in x prime equals 0 and x prime equals h. We end up with the same thing. So I
Now,
think
why is there no squared? Is that because they did the square root of A dot A? Because they don't have a squared on the bottom.
That's a good point.
Was I wrong to put that squared there? I thought I was looking at this and I thought when you took the second derivative you were going to get a squared thing on the bottom, but maybe I'm wrong. Doesn't this 2 come down here?
Hmm.
Let's just check it. This equals. Yeah, I mean, if I take the second derivative of that, the 2 cancels this, and then the tau goes away, and the h goes away. I think that's checking out. I forgot to put the 2 here. Oh, whatever. All right, well.
Yeah, I think I can't explain that part. I don't know.
I feel like overall it was a successful day.
Yeah. We need a bit of a push for these questions from the solutions or or chat, but
Yeah, the last one was hard.
yeah.
This number 7 was hard for me.
Yeah, same.
Number 6 was pretty good.
Yeah. So I guess do you want to move on to chapter 7 for next time?
Yeah.
Okay.
For sure. Do you?
Yeah. I started to read it and it's only getting crazier, unfortunately.
Oh no, don't say that.
The notation is they really press on the whole alpha beta stuff with the subscripts and superscripts.
Oh, okay.
So it's getting really messy.
I see it here when they're talking about metric.
Yeah, let me. Okay, I'm on page 140. This might be the most intimidating looking like page that we've seen, that I've seen in the entire book. But it's an example problem.
12 expressions here, and they're saying, are these kosher or not? You gotta work it out. Oh,
and so they give you rules to kind of like evaluate them based on right before this, but it's like this is just a whole mess of letters here.
Summation convention. Yeah, okay.
Yeah, so
chapter, you know what? Chapter 7's long, isn't it? Well, maybe we can, yeah.
Yeah.
I don't know if I'll read the whole thing. We'll see.
Yeah, we can figure something out if we don't get through the entire thing. Do some more chapter 6 or just do certain ones from chapter 7.
Yeah, I'll start reading it. It looks cool.
Okay. I think cool is relative, but
Yeah.
yeah, I think page count wise, it's not that much longer, but I think content wise, with all the summation stuff, I had to go back and revisit where they introduced it to remember what they were saying.
No, it's long. It's like 30 pages.
Oh,
Oh, maybe that's not too much longer, but
me
a little longer.
135 to 158. Oh yeah, you're right. At least 33 compared to the other ones around like 20 to 30. Okay.
And then chapter 8, geodesics.
Yeah, I see. Okay, that one is that's like a 10-page difference, like in the table of contents from like the start of 8 to the last section. That's nice.
What's your plan? How far do you want to go?
Chapter 9 is kind of the goal, like including 9. So not that much more. Yeah. I think Cook called out like skipping, if we want to go past 9, skipping to 12 might be a cool one. Gravitational collapse and black holes. But yeah, I've had 9 in my head as a stopping point. So theoretically, that'd be like 6 more weeks if we keep on doing 2 weeks per chapter.
When's your fall semester start?
September, it's like 22nd or something.
So you got plenty of
time. Yeah.
Yeah.
Because I wouldn't mind like wrapping this up. Just so I can focus on like the complex analysis stuff and all that. So
yeah, no, I hear you.
But I don't know, this is still like super cool to learn about. Even if I'm not like getting all of it, I can only say that I've tried with general relativity, or we both have.
Yeah, I mean, I just consider it a first attempt. So if I pick up a little bit, that's a win.
Yeah, it's gonna always be a thing that we like revisit when I have more time, or something like that too. So
yeah. All right. Well, then I'm going to leave you to it.
Sounds good. I'll see you later.
Yep. Thanks again.
Yep. Bye. Okay. Whew, that's a freaking doozy. Let me get some music going. We'll switch it into doing math. Unpin. Okay, let's change the Twitch title and category. We change the YouTube stuff. Where is it? Nope, not that thumbnail. On that thumbnail. Okay, nice. Oh, did that actually get copied? Hey, meet Milocaz, welcome in. Do you think you can understand this kind of thing without knowing a lot about physics at first? General relativity? if you know even basic mechanics, you can get by pretty well. Like just know like what the equation for kinematics are in energy. Uh, and that's kind of all that we've really leaned on so far. I'd say in general though that the ideas that we've been trying to learn are really freaking like sophisticated and deep. And it's just like a lot of critical thinking, I guess. Not even necessarily physics in particular. So I guess the answer to your question is yes. You should. I like. It feels like you definitely need to be really strong in the math. The physics is almost it feels more negotiable to me for some reason. Um. Okay. Oh, get that out of there. No worries. Were you using the iPad again? Hopefully that's been working better for you. Oh yeah, I do want to take a closer look at this solution. That's pretty sweet. No headphones too. Oh right, yeah. Where the heck do they get these from? Um, yeah, I wonder. I feel like they're using these here and setting dx prim equal to 0. That's what I'm trying to go through and check right now. So the time component, they end up with just cosh. I don't see how. Shouldn't they have this factor involved too? For cinch, it's the cinch. And that goes to 0. I'm concerned about those x primes in particular. They don't look like partials. I think they're letting. Oh, um, that's where the factors go. Okay, so they're saying dx prime equals 0, and then that factor times dt prime is d tau, and they divide the d tau over. And they probably do the same thing for x. Okay. Okay, now I get these. Components of the forward acceleration arm. Let's take two derivatives. Ooh, how do t and tau, or t prime and tau interact here? I think they're doing some chain rule stuff there. Hmm. It's annoying. But all right. I think I understand where this answer is coming from. This is the solution key to the problem we are just working on for general relativity, Lucas. I think we'll have to switch away though from this. Uh, yeah, I think they're saying they're making that to like dt over dt prime times dt prime over d tau. And I think the t prime over tau part is just going to be. Oh, I was making it 1, but that doesn't make sense, does it? No, I think it's 1. I think it ends up that taking the derivative in t prime is the same as taking it in tau. Hopefully that tracks with how these equations actually look. Actually, it really doesn't look like that. Maybe, okay. Let's go to a journal plus plus. Okay, so this is it's weird when it's a second derivative. It has to do with this. Um, yeah, I have see. I'm getting stuck on this being a second derivative. Um, I know it's the chain rule. I try to figure out how it applies here. I'm just weirded out by it being a second derivative. Maybe this is how I need to think about it. I think this is it. And then this is equal to that. 1 over that. And that's where that factor comes from. And then the G over C sinh is from the regular derivative in T prime there. Okay, it was this weird... It was this thing that I needed to write to make this make sense to me. Let me write out what you just put. D over D tau. dt over d tau equals d dt prime very last t should be a tau. Okay. Um, oh no. I didn't write your first step. So basically saying the d tau part is equal to that piece. Should this bottom thing be flipped? I think if it's flipped, then I can see it. Flip it? Okay. Yeah, okay. Then if I just treat these like fractions, then yeah, that makes sense. Okay, nice. Yeah, I was getting confused on how to use chain rule for like when you have just the D in the numerator. I really, I like. Is there a good notation for derivatives? I feel like they all suck. I guess that I think is what the big D derivative is supposed to do, but no one uses that. Okay, I did have an idea for what I want to do though. Um, if there aren't questions from chat, let me grab it. See. Let me also bring. I don't know, but I know. I once I stop being lazy, I'm going to make my bot put a comment in chat. Like when I start the YouTube share, I make a bot put a comment in chat saying like, "Sorry, but I don't know JE Advanced." On reading group days, those tend to be much less popular with YouTube. Uh, and so yeah, now I've changed the YouTube title, something can be the problem. They might start coming in, but on days where I just have like the reading group, they're usually way less people in general. Um, okay, so he's talked about this publicly, or at least in his Discord. So I think it's okay if I mention it. Let me just confirm. Yeah, okay. So uh Shane Micken is having a little like a I don't know what it's called, like a little symposium thing where basically a bunch of his friends are gonna come to stream and explain like what all they do. He asked me to give a little talk. And I don't want to give too much of it away, but I thought a little piece of it might be fun to try and figure out on stream. And so for what I want to say, um, I want to steal from this book called Calculus in Context. It's very much an applied calculus book. And they go over the Lotka-Volterra equations, but they don't give a phase portrait. And I want to make a phase portrait because I really like phase portraits. And so I want to figure out how to make one in Python. There's no bookmarks in this PDF, unfortunately. Yeah, and so I've done it in MATLAB, and if I was trying to do this like back when I was at studying, this would take me about 5 seconds to accomplish. um, but I've forgotten how the hell this stuff works. So these are the equations we're going to use. These are the parameters we're going to use. They give this for the solutions, which is really cool too. And I'm probably going to screen grab this. But I really like phase portraits. I think they're just fun. They're very intuitive, I feel like. I shouldn't have closed out the tabs. Python phase plot. phase portrait. And so this is the bones of what I'm gonna copy, because all I do is copy. That's what I'm best at. We need a new file though. What should we call this file? Lotka-Volterra phase portrait.py. What is this? Do I need to select a language? Do I not have a language? Go away. No, I hate it when there's text there. Okay. The name? Oh, like the book that I had? I don't want to lose my page number. I guess I'm page 213. There. I need a screenshot of this shit. Okay. So they present them as r prime equals ar minus a over b times r squared minus crf. So they use rabbits and foxes for their two species for the Lotka-Volterra equations. Just any predator and prey combination will do. And they say a equals 0.1, b equals 10,000, c equals 0.005, d equals 1, 2, 3, 4, 4, e equals 0.04. Okay. Actually, we should really just do that. You don't understand how people enjoy coding? I I like coding until I have to write something that's more than like 30 lines. I think coding gets very tedious very fast, but you can do some really cool things in coding. I really love the concepts of computer science. I just hate actually accomplishing things in computer science. uh, oh, do tell, Lucas. Now, why are you yelling at me? Quick fix. Give me that quick fix. Nope. Master in maths, then a master in astronomy, maybe a PhD in black holes. That you are setting your sights high, but I mean, hell, may as well aim high. Yeah. Um. No, I agree. You should absolutely aim high. Um. I'm trying to think of like astronomy type streamers that stream during the day, or like stream at a time that isn't terrible for you. But to be honest, all the ones that I know stream at night, like during the night in America. Dreaming about it and continuously wondering why like I didn't think about the cost. If you want to do something in life, you should just do it because you're gonna be sad if you don't do something only because of the cost. In my opinion. But would you have to like pay for? I just kind of assume that anywhere in Europe you don't really have to pay for stuff like that. I just mean like for watching a stream. Like there's a bunch of great astronomy streamers who I know. I just don't know of any of them that stream at like EU friendly times. But I can start like naming people if you want to like get more into it. Like Moodles is awesome, Astro Canuck, Astronomy Show, Jason. I'm probably forgetting someone. But those people come to mind immediately. Yeah, sure. But yeah, like it they stream it pretty like I think terrible times for you. How applied? Oh, astronomy. That's like the definition of applied. You're studying the actual universe. Black holes. Yeah, I mean that that's about as applied as it gets. That's the exact opposite of like when you study math, there's a pure side and an apply side. When you study physics, there's a theoretical side and an experimental side. But at the end of the day, it's physics or astronomy, and so it's all applied. Like it's just to me, applied means how related to it, how related to the actual universe is it, like as it is, and that's pretty freaking applied. Your side is what you like the most. Okay. And so yeah, like what you might do is like a theoretical person is try and create different models or like different equations to represent black holes and evaluating how those match up with real data. Yeah. She's not specifically about space, but there is Tiny Toxic Tofu, who's Irish and is a physics professor. I've seen her giving talks about like mechanics a lot, I think, and I think some E and M. And yeah, you can like you don't have to sign yourself up to only be on one track and do on one thing. But if that's what you feel like you want to pursue right now, try to pursue it. And if you end up in some other place, like that's not a bad thing either. That's the important thing is that you enjoy it. You don't have to lock yourself into one thing right now. Urban sources physics is shit on high school, but very nice on uni level. That's how I feel about physics. I mean, honestly, I didn't enjoy physics in high school or in uni. um, I probably would have enjoyed it in uni if I got to the more advanced physics classes. But I think physics is pretty boring until you get to use multivariable calculus, basically. Till Kernphysika? I wonder what that would be. What? Oh, dude, my fingers are on the right keys. That's not English. Nuclear physics. Oh, nice. You're learning about nuclear physics? Are you just like the half-life of an atom, or like? I don't know what nuclear physics would even. I know it's a field of study, but I don't know what they actually like learn about, I guess. Where do I put this? That's my question. Can I just guess that it goes in here? Oh my god. Okay. That works. So now I need to define a function. Def Lotka-Volterra. RF. Talk about radiation, different types of strata, and oh, okay. Yeah, like black body radiation. I remember trying to do a problem involving that once. So just get combined. Yeah. The cool thing about studying more advanced fields is you learn just how connected everything is. And when you first learn something, they always teach it. They try to simplify it, but once you simplify it, you lose all those really interesting connections between things, which is kind of a shame. Can't wait to get up to learn French anymore. Ugh, fair. So return first the rabbit equation. A times R minus A divided by B times. Oh, R star star 2 is R squared minus C times R times F, comma. D times R times F minus E times F. That guy's still just making me wait until I can do the fun stuff. Yeah. I see the argument for making people take a variety of subjects, but man, it's just annoying. My naming convention is all over the place. And who cares? It's just more fodder. I'll just send it to Phobos to roast. Okay, so here I think negative things don't make sense. I'll just put that out to 20 for fun. I sure hope the X label is rabbits and the Y label is foxes. I don't really know though. Just run this and see what happens. Did it work? I don't have any windows. It opened. Did I need to show it? Why are you angry? I don't get it. My responsibility is to start to deepen your connection with a certain subject, or like veteran search not 14. um, I don't know. It is kind of true that you need a baseline knowledge. To some extent, like you shouldn't skip past the basics. Before going on to the advanced stuff. Your old English? Oh my god. I don't even understand old English. Yeah. I don't like that's kind of an interesting question. I don't have a very strong opinion on it. Like I just kind of feel like I need to hear what the arguments are. Like I don't know what the argument in favor is for general education. It feels like saying it makes you a more well-rounded person is kind of loosey-goosey. Like, how exactly does it make you a better person? Or what's wrong with specializing earlier? Yeah, we were forced to read some books in Old English, like Shakespeare or Canterbury Tales, but we were supposed to. I never did. Oral, some poor guy at the back of class is trouble to deep and still waiting for someone to catch us up. That's fair. You know what? That's actually a really good argument, Boral. Boral, I forget how to pronounce your name. You are kind of unique, Lucas, in that you have a really good idea of what you want to do compared to most kids. Or sorry, I shouldn't say kids, but compared to like most people your age, I feel like most of them don't know what they want to do. That's probably the best argument in favor of general education. I don't. I'm just thinking about when I was in high school. If I asked most of my friends what they wanted to do, they would tell me that they don't know. I didn't know either. But you have an idea of what degrees you want to get in what fields. It's pretty specific, and that's not a bad thing. But I think it's uncommon. If you find something interesting, drop everything and study it. Yeah, I like that. I think it takes most people a lot longer to find something interesting, I guess. So if I copy and paste their exact code, does that work? I need to get the function. I did get the function. Divide by 0. Yeah, what's the question, Lucas? Problem nobody else recognized yet? Maybe. It's a good question. Yeah, we'll just start with sine. So the intuitive reason why, so the answer is does not exist. You would say it diverges. It does not go to infinity. Diverging, well, wait, does diverging mean you have to go to infinity? Not necessarily. So, yeah, I mean, I'm pretty sure diverging is still the right word to use here. I think it's often defined as, I think diverging usually just means not converging. And there's different ways you can diverge. You can diverge by shooting off to infinity, or you can diverge by what we would say is like oscillating, where you just never quite settle on just one value. Thank you, KMK. Welcome in, by the way. Do you do pure math? Like, where's the 4 and the 4 legs on a dog? What? Where is the 4 and the 4 legs on a dog? Can you say, so, no, you can't. So you're giving me an interval, Lucas, or I assume you mean like, you're making the argument that sine is bounded between -1 and 1. And it's true that sine is bounded, but no matter how far out to the right you go, it doesn't settle on just one thing between -1 and 1. That's the important thing. And so a limit, you have to say it's just one number. And so you have to say what specific number you're proposing. If you want to claim this limit converges, you should say what number you think it converges to. And so as soon as you choose your number L, I could go to, I mean, I would struggle with it, but I could go to epsilon delta and show that there like no such delta exists, basically. Like there's a way that you can show that limits diverge using that too. Oh, like what is 4, you mean? I'm much more of an applied math person, personally. Is math invented or discovered? I think invented. It's kind of an opinion, but like I feel like since it's axiomatic, that feels pretty invented to me. Uh, Bilu, you want to differentiate this? We can do that. Oh, Slim. Nothing gets Slim out of a lurk like a math philosophy question. In Slim's Academy uses ideas for those who don't know. I kind of think since math is axiomatic, that makes me feel like it's invented. Nothing about math is inherently true, or like math is only as true as your axioms are, I guess. At best. We invent the system in which we work and make discoveries within the system. That's a fair way of thinking about it, Captain Blacksmith. You feel like math is discovered, Fembox. Yeah, Lucas, it is a power of a half. And so that's a helpful way of thinking about this problem here. It's a very annoying derivative to do, by the way, but we can do it. So we think of this with chain rule. I don't. I guess. I don't. I feel like math is like you just you decide on some axioms and you prove whatever you can with it. That feels like an invention. It has no relation whatsoever with how the universe actually works. Inherently. You just have to hope that your axioms do relate to the universe. I don't know. I'm feeling less confident the more I explain my position, but that's why it feels invented, I guess. Sounds good, Boral. But yeah, if I'm doing the chain rule on this thing, I'm going to start by looking at the outside. So we have a power of a half as our outside function. So the 1/2 comes down, and you get 1 plus sine x over 1 minus sine x to the minus 1/2. I need more room. But now we have to multiply by the derivative of the inside, and that's a quotient rule, and that's annoying. We don't like the quotient rule, but we have to use it here. So low d high minus high d low. So 1 minus sine x times the derivative at the top, just cosine x, minus high d low. So 1 plus sine x times the derivative at the bottom. I need even more room. The derivative bottom is minus cosine x all over the bottom squared. Now, this is technically the answer here. We can try and simplify it though a bit. I'm not going to simplify it too much, but I'll simplify it a bit. I'm going to get rid of the negative sign by flipping the fraction inside. Minus sine x squared. One half, 1 minus sine x, 1 plus sine x. Oh, sorry, Lucas, was your question about sine? Did you want to talk more about that, or do you feel like it was answered? I kind of got distracted. The same argument would apply to tangent and cosine as well, that I was saying before. That cancels, that cancels. 2 cosine x over 1 minus sine x squared. Okay, and that's about as much as I would do. The 2 and the 1/2 can cancel. I would say this is the answer here. There is more you can do with this. I don't think it's all that helpful. Like the 1 minus sine x's, they can cancel, I guess. It's going to make the equation look a lot uglier, but we can do that. One minus sine x to the 3/2. I guess I would say this is my answer. Way by quotient rule is to write 1 minus sine x as. Oh, that's clever, Lubert. So yeah, if you wanted to avoid the quotient rule on the inside piece, you could say that the top here is the same thing as negative 1 minus sine x plus 2 over 1 minus sine x. I'm just checking this. Yeah, that. And so if you simplify this back down, you do get 1 plus sine x. But the point of doing this is that you can split up into two fractions. And that result is simpler to take the derivative of. Because you get negative 1 plus 2 over 1 minus sine x. So yeah, and this you can avoid using the quotient rule for. So that's another way of doing it too. You do feel like it's answered. Okay, nice. I don't know if you have any questions for that, Bilu. Okay, let me catch up with the philosophy. Math is true in different universes. Physics is true in only our universe. I can kind of see that, KMK, but yeah. Conversations to everyone here, but I enjoyed everyone is thinking. Yeah. Discussion is the fun part. If we were aliens living on a far distant planet, thinking about things mathematically, when I'm discovering something about the ratio of the circumference to its diameter. That requires experimentation, though. I feel like. Okay, I mean. I almost want to say that falls under the realm of physics because you need to physically take a ruler and make a measurement in the real world. Like you can approximate pi by using a string. Like you lay the string out flat, measure its length, form the string into as perfect a circle as you can, and then measure the diameter, and then divide the two. That feels like a very simple physics experiment, I guess. But I don't know if there's another way of thinking about pi that wouldn't require that. Different philosophical point of view is that the axiomatic method is more about verifying merely discovering true statements. The axiomatic method came after we had already discovered some math. That's fair. Yeah. How can you know that others around you really live? I feel like you don't. You just kind of assume other people are the same as you for the most part. Central, yes, I do hate you. I specifically programmed the bot to not send the go live message to just you. It should have said that I was live. I fixed it, I thought, so it gives the right links. Yeah, it said I'm live. You just hate me. And yeah, Lucas, you can, I think you can simplify that. Bilu actually specifically said no rationalizing. So I didn't try it, but I think you could do one of these bad boys. And get something potentially simpler. Because this is cosine squared, is the point. And it can come all the way outside the square root. This is still kind of an... Oh, wait. I shouldn't have multiplied that out. The square root of that thing is just 1 plus sine x. So yeah, you're right, Lucas. This thing does simplify down very nicely. That's so much easier to work with. Your name usually shows you're live. Oh. Bro, I literally I see what you mean, Central, with like my status. I literally disconnected the Twitch integration and reconnected it, assuming that would fix it, and apparently it didn't. That's annoying. I guess I'll try disconnecting and reconnecting it again. Falsity that claims you're the only thing being it's called solipsism. Usual criticism of solipsism is that it's not falsifiable. Therefore, it's not interesting as a philosophy. Oh. That's my exact issue with a lot of philosophy, is that it's not that interesting to me because you can never disprove it. Yeah, I had it randomly break on me before. When I changed my name, I made sure to unlink it and link it again. But maybe I need to do it a second time. I also have that in my end answer? Sorta, yeah. Things get kind of flipped around. Why is 0 factorial 1? My understanding is that we just say, everyone just agrees that it is 1 because it's convenient. It makes our formulas work. Like it keeps the pattern for how we want our formulas to work, basically. And I don't think it's a reason you couldn't say it's something else, but saying that 0 factorial is 1 makes the things we do with factorial much easier. You don't need to make special exceptions for 0. When neuroscience gets really far, it has effect on philosophy. Really? I know nothing about neuroscience. Okay, so I was working on the Python thing. I think 0 factorial is 1 because a factorial is how many somethings there are if there's nothing to speak of. No, not to me at least. I mean, there's a way you can interpret it with like number of ways to order things, and there's one way to order nothing. I think that's a way of thinking about it too. One is multiplied by any super reasonable. If you don't multiply anything, you get 1. That's an interesting way to think about it, son. It is a logistic convention you agree on, yeah. Could evaluate gamma of 1. Oh, Zach. You sure could. You might not want to, but you could. Dreamland Minecraft, there's no way in hell I can do that question, I'm sorry. If nothing is nothing, it is still something. Because to speak of nothing, you are speaking of the absence of nothing, which is something. Kinda? That's not what a factorial talks about, though. I mean, I guess if the things in your statement are permutations, then sure. Hey, Zishan. Billu? I don't know about that math. Take my piercing credentials? No, I'm okay. What is Gamma of Dawn? True. The answer everyone wants to know. Darshil, I'm sorry, that's not really my strong suit. I don't know much about it. I feel like I need to make this pin in the YouTube. So if you have a JA question, I'm sorry, but I probably can't do it. Zishan, if you want to try me, you can, but if it's JE, there's a good chance that I just can't do it. This is annoying. Zishan, you can type it out there in chat or put it in the Discord. I'm really annoyed why nothing shows up when I run this. What if I try to? I don't know why they're dividing by 0, but if I just do that, do I get something here? No. Why? Bruh. Give me the phase portrait. Communication engineering? I don't know. They're called phase portraits. Um, they represent families of solutions to differential equations. I'm trying to make one, but it's not working out well. I would have copy pasted this code and it's not working in for me. Hmm. I could just do it not using this weird phase portrait library or thing. I just try to make the vector field myself. Maybe it plots on Jupiter? Did they say that? I know, this is just like the first thing I found off Google. Um, I at least with like I with like matplotlib, I, I've had like a window pop up where I've graphed things, but before. Phase portrait is completely new for me. But like if you do other graphs with Python's like built-in matplotlib, I think it's built in, I don't know. A little window pops up. Is this live beneficial for me? Oh, it's extremely. I learn a lot from the people in chat. Okay, maybe let's go back to the drawing board. So I wonder if this is just not a common thing for people to use. So there's not gonna be a lot of Stack Exchange stuff on it. This isn't much more complicated. Um, I think when in doubt, copy and paste. No more face portrait. You don't seem to work. Um, what do the fixed points? How are we using those? Oh, we don't need that. I mean, I might want that later, but we probably won't need that. Here is where we want. Rabbits and foxes. Uh, F times F. Oop. See what this does. Show me the money. Are you showing me the money? I can't tell. Is it still running? Oh, it flickered for a second, and then it went right back away. Um, Yeah, that's weird. It just flickers for a second. Start the process and end it? I could like, I don't know if that would do it. I mean, I could try just closing out of this. Hmm. And reopening it, but I don't know if that's going to do much. Yeah, it's still just flickering for some reason. Um, it shouldn't be that. Oh. PLT.show? Oh! We got a phase portrait, folks. You won't be able to see it. I need to get better bounds, though. I don't know what the best bounds are. I might have to go into the thousands, actually. Um... Okay, okay, okay. How do we find the stationary points versus differential equations again? Do you take both derivatives equal to 0? Yeah, right? That will be a stationary point. Okay. Can I make Python do that for me? Or can I make Wolfram Alpha do that for me? Uh, uh, or surely someone else has done this before me. What am I looking for? Stationary. Well, that's one of them. That's the Oh, okay. Yeah, Zach, I'm trying to make a phase portrait with them using it's like a book that I think I probably found from you, Calculus in Context. I want to make a phase portrait out of what they go over in chapter 4 with the Lotka-Volterra equations. Using Python, because that's just what I happen to know, or I allegedly know it. Just like matplotlib. And so I figured out how to make it. Well, actually, here, I'll just. It's not easy for me to show it on stream. take a screenshot of it and show that though. Really, I've figured out what the proper code to copy and paste from Stack Exchange is. The issue now is I'm trying to figure out what the bounds should be. And so I want to, I assume I should just base that off, including all the stationary points. So right now I'm just going 0 to 10, but I needed it to be a lot bigger. The parameters are the ones that here. So I assume I could probably just plug this into Wolfram Alpha and make that solve it for me numerically. Maybe that's the best thing to do here. I was just hoping to like quickly find a formula for it based off the parameters, but maybe I just do the slightly painful thing of typing these into Wolfram Alpha by hand with the parameters plugged in. Their explanation, so that was a little bit of a sketchy thing where I didn't fully understand it from the book's explanation, but it has to do with the number of rabbit fox encounters. That's what the rabbit fox unit is. Yeah. And so I didn't fully understand why we're multiplying the two as opposed to something else, but I'm just kind of going with it. But I think what I'm going to do is just take a screenshot of that and then start plugging stuff into Wolfram Alpha. Rabbit is X, fox is Y, 0.1 X minus 0.1 over 10,000. Well, yeah, but why multiplication and not addition or something like that? Or like, I don't know, like log of X times Y or something weird. Here we go. So maybe I'll go out to 12,000. Maybe I'm concerned about that one getting lost. Let's go 11,000. We need to do bigger steps, right? Should we do hundreds? That might be too much. Oh, well, that's not good. What the hell? I'm just getting horizontal lines now. Really? Something's wrong. Just go back down to 10. Okay, so what I'm getting now isn't that. As I zoom out, so this is zoomed out a little bit, only out to 100. Below, this is Python. The stationary point all the way, wait, where is it? Oh, it's at 10,000 comma 0. Maybe that's not such an interesting stationary point. If I zoom out to 1,000 even, these just become horizontal lines, like straight horizontal. And I thought there would be more, like, I thought you get more of like a flowing, like circular thing. Just stretch out the x-axis. Maybe that's the right call. Yeah, just the x. X is rabbit, yeah. Oh, okay, maybe that is what we want. Let's look a bit better. I'll show what it looks like. Might want to push it a bit further. Maybe bring the Y down. I gotta think that it's still wide. But yeah, what I really want to emphasize is the kind of circular flowing nature of it, as long as you don't start too much to one extreme. I'll make catch up with your previous comments. Xy equals c for some constant is hyperbola. When nomenclature dominates, there is a larger value of the denominator. Paragraph 2 in there. Yeah, underscore. Wait. Is that the right one? That's not the second paragraph? 1, 2? Do I not know how to count? Isn't this the third paragraph? Is that the one I'm supposed to look at? The section before? Okay. Oh. Oh. Okay. Around 3,000 in the book's plots. Oh, I should have looked at that. Duh. The foxes go as high as 3,000. Rabbits as like 2,200. Oh, okay. I like that. That the product definitely accomplishes that piece. Okay. That does help a bit. I thought it was interesting that the way the book was talking about this, like the rationale for R times F being involved in rabbits was different than the rationale for R times F in foxes. And this kind of the Wikipedia page hints at that a bit too. Game of predator is opposite for prey, yeah. Um So let's keep on pushing the bounds for this graph here. Let's go 3,000 in the x. Let's go 3,000, 3,000. I probably need to make it, that's probably bad. I probably need to make it wider than it is long. Yeah, that's too much. So let's chop it back down to 100. Oh, I chopped the wrong thing. Wait, what? I did chop the wrong thing. Ooh. Hey, Suffle. Oh, this is a nice looking face portrait. I might need to refine it a bit more, but let me show this one. That's a nice face portrait. Just look at it. Bask in it. Mr. Factorial himself. That please, Mr. Factorial's my father's name. Look at the axes. Cook would say sexy. So I'm debating if I want to see how it looks if I put the y-axis down to like 50. But that's looking pretty good already. Ooh, I like that. I like this more. Um, when I was first taught these, I was uh shown that the intuition for these is like you imagine this is the current in a river, all these vectors, and you drop just a leaf in this current and follow where the arrows take you. And that's the example solution giving like where you place the leaf is your initial conditions, and then where the arrows take you is the behavior of the system. And I just love that. I think it's amazing. It's not a sync. It's not exactly a sync. This might be a sync. I don't know. It's kind of hard. It is syncing a bit. But basically, I need to label the axis. I need to figure out how that works. The horizontal is the population of rabbits. The vertical is the population of foxes. Oh, and Zach, I'll show in a second. Hey, Orange Hue. Yeah, it is pretty vortexy. And so if the rabbits spike up, that makes the foxes spike up. But the foxes spiking up eat the rabbits, which make the rabbits go back down. The rabbits going down makes the foxes go down, and then the thing kind of repeats. I think it reaches an equilibrium. It doesn't go all the way down. Matthew on the YouTube side. System of equation as the book shows it, or as I'll guess as the book shows it is what you want to see, Zach? That system with those parameters. Oh, I did that in Wolfram, I guess. But in Python, I just whatchamacallit? I did like variables. So like I don't think that's what you want to see either. The graph? Okay. So there's a stationary point, Wolfram Alpha found 10,000, 18. Oh, 10, wait, 10, no, 1,000, right? Yeah, 1,000. There's a stationary point right the heck there or so, which makes sense. You want to show me something? Okay. Right, like you let them both equal 0. I just didn't want to. I was just being lazy, I guess. um, but like you would just let them both equal 0 and solve that, right? Hey, Ganesh, I'm just making some phase portraits with the Lotka-Volterra equations. Um, I can you solve them like with arbitrary constants? That's the thing that I was looking for before. Maybe you could. I bet you could. But yeah, you just let that equal 0, let that equal 0, solve for R and F. Um, oh yeah, you could definitely. Okay, you know what? Maybe we'll do it by hand because it's really not that bad. Hey, Jasu. It's like with this equation. Um, well, you have to be careful with that one. You don't want to let the F's cancel, right? You're buried by marking. Oh no. I hope you get through it. Maybe we want to work with this equation. My R looks like K. Yeah, and so now with the second one, we get 0 equals D E. That's annoying. Oh wait, it's not annoying. It's not annoying at all. I was about to say we have to multiply it out and factor it, but we've already factored it, haven't we? I'll have to make a lot of work for myself, wasn't I? Is that just B? We do have to check R equals 0 manually. For sure. Yeah, $10. Yeah, R equals B. Um, and so that means F equals nothing clean. And F equals, oh, 0. Nice. Conditions are a pair of lines in the phase plane. Wait, both equilibrium conditions, pair of lines in the phase plane. Are these lines? These don't look very linear to me. I guess F is linear with, oh, I guess I did rearrange it. Yeah, maybe it is linear. Yeah, okay, fair. I mean, this one is weird because things like cancel. Or if you're not careful. I don't know. Anyway, does that match with the critical points Wolfram got? Two lines where r prime is 0. Oh, because of equaling to 0. Yeah. Aren't all pens colored? Not invisible ink pens, Jasu. Uh... I need scientific notation for this. A 1,000. Good. That's one of the ones that Wolfram got. This annoying thing. Invisible ink can be seen under UV light. No, infrared isn't a color. It's simply not a color. We can't see it with the human eye. I mean, well, how are we defining color? Is color just wavelength, or is color actually human perception? I don't know. Oh yeah, Fenbox. We got phase portraits. I need to figure out living the axes and stuff, but I'm not paid enough to do that. .1 over 0.05. 20. Wait, Wolfram Alpha got 18 for that, didn't it? Oh, that's an interesting thing to check. I wonder if I can figure out how to plot that on the same thing. Never getting paid, I wish. Well, I mean, I technically am getting paid, just like a couple cents per stream, though. Wait, I forgot a piece of F. That's why. Wait, what am I doing? Am I going crazy? That's just A over C. I forgot the entire rest of this. There we go. I'm definitely not paid enough to do that. This music reminds me of Baba Is You. Paid with knowledge invaluable. It's like paying an artist in exposure. That's 18. Okay. Scientists are invaluably homeless. So this is one equation of the line. Is the other equation just R equals, like, we just cancel the F, right? for that stationary point. Or we set f equal, well, I don't know. No need for homes, just be in the lab. Oh, well, Jasu does physics slash chemistry slash rocket science slash biology slash everything. So she has a lab. 0 to 0, like as a ratio? So I don't know. I don't think it's defined. Yeah, I guess it's the same thing as 0 divided by 0. Computer lab, sure. Yeah. Even mathematicians have those, I guess. What am I doing? Oh yeah, so I'm kind of interested to see Fembox's thing about plotting lines. So I think we're gonna have, what is E over D? 10,000? 10,000 or 1,000. We're gonna have one vertical line at 10,000. That's a good thing. 0 in the field, 0. Half of 6 plus 6? I would say 6, but there's an order of operations question there. Okay, you know what? I don't feel like figuring out how to graph a line in Python. Right here, Bedlocks. You're gonna make it bigger. Can you do a phase portrait in Desmos? I assume you can't. Man, I freaking love just looking at this. Wait. Yeah, I guess keep it out because I'm planning to use this. I think as soon as Friday. I'll put something in my Discord when I know for sure. But this is gonna come in handy for me very soon. I think it'll be around this time of day too, maybe a little bit later. Maybe no, I think it'll be earlier by an hour or two. Diffusion plots. I bet you can use, well, oh man, I have no diffusion plots. I feel like I do. It's just representing like the movement of gas or something. Ooh. Equivalent to the heat equation. Oh, nice. Sometimes. Remember Zach was talking about that. I could see there just being like vector fields represent diffusion though. Ooh, they're going like linear algebra. Oh, you're giving me the equations of the lines? Okay. Can I figure out how to graph? I don't know how to graph a line in Python. Really? It just makes it a line for you? I guess it connects the dots? Yeah. Um, so linear line, it sure is, Tyler. Blue lights? Hell yeah. Let me set some blue lights. Um, I think I'm smart enough to figure this out, maybe. Um, this is going to be annoying with wait. Ah. Uh, not R. I don't think I am smart enough to figure this out. I just want it to be. This is okay. We can do the other one first. I actually can figure that one out. It's the vertical line R equals 1,000 that I don't know. Where does it? I'm failing on that. So I need to make an array of the right size. I don't really know. I don't know. I don't remember how this works. Can orient the phase diagram using the sign of y prime and x prime. What do you mean by orient it? Doesn't it just have its own? Oh, interesting. Um, some. Sorry. Size. Um, okay. Hopefully that works. Um, don't quote me on it. The next two dot. So I'm saying, uh, will just be R. Am I doing this right? Maybe. y2 dot is going to be rearranging Venbox's equation. Hey, Doomwood. I'm solving this for f. 10,000 divided by 500 is 100 divided by 5. Is 20? Question mark? Yeah. I could be royally messing this up. Let's find out the hard way. Bruh. Nothing much, Doomwood. Just trying to figure out some Python stuff for graphing. I don't feel like figuring this out, guys. I'm gonna be honest. I'm getting tired. My voice isn't doing great, like usual. It's been a 4-hour stream. That's kind of usually past my limit. I that would be really interesting to see though, Venbox with dividing it up into the regions of increasing and decreasing rabbits and foxes. Because I have not seen that before. I don't think I was taught that at least. But that might be a task for another day. Or it's not on stream. So our second year A-level syllabus, you've heard most of the calculus stuff, man. Oh, dang. Good luck with it. Yeah, I'm still rusty on Python. Parametric integration, Doomwood. I you post it in the Discord and I'll get back to you. I'm kind of losing my voice here, Doomwood. Oh wait, is that what I messed up? Or is this what I messed up? I'm messing something up. I don't know. Yeah, I'm messing something up still. Maybe I can try and do this quick. I don't know. Let me just bring up Paul. Aren't these the same thing? I guess the bounds. Mesh grid basically takes two one-dimensional arrays and like it makes them your axes and it fills in everything like the entire like quadrant one or whatever if you want to call that. So I'm losing my voice here. I'm about to call the stream. Okay, yeah, Dimwad, I'm gonna get back to you off stream. Um, I can do your question. I just want to stop talking right now. So I'll write you a message. Or like I'll reply back to you. Um, yeah, I need to call there. So thanks everyone for hanging out. Dimwad, anyone else who's here on YouTube, I'll be back on YouTube on Tuesday. So yeah, see you later, YouTube. I'm sure you'll look for a raid.